In this module, we will study some quantitative techniques for risk analysis. Risks has everything to do with uncertainty, and uncertainty has to do something with probability. So we will look into some probability aspects of risk management. Let me refresh your memory on probability. I have a question for you. What is the probability of throwing a 6 with 1 dice? In order to estimate this, we need to know something about the probability distribution. This is the probability distribution of throwing with a fair dice, and we can see that each number has the same probability to occur. We have a formula. When we add up the 6 probabilities together, we always get a chance of 1 or 100%, which is actually the same. That one was very simple, but when I would ask you the question, what is the probability of throwing 7 with 2 dices? This is not so simple. When you would look at it, you can prove it mathematically, or either you can try to come with a percentage, with a probability distribution, doing it empirically. By experiment, you can see that the probability of getting a 7 is the highest. Actually, we have 36 probabilities, which add up to a 100% probability. Let's see how this works. We have in total 36 combinations, and from these 36 combinations we have 6 combinations which will add up to 7. And now it's very easy to calculate the probability of throwing 1/7 with 2 dices, because this is 1 out of 6. For dices this is very easy, but for a lot of the risks that we have in project management, it is a little bit more difficult. Let me explain how this could work. When we have experience with a typical activity which we have done again and again, then we could look into our history files and we could see the different durations that it takes to do a certain activity. Let's, for the sake of this example, let's think that this is the amount of days in preparing a plot of ground for some building activities. This is somewhere between 23 and 14 days. The average duration is 17. So it does make sense to put 70 days into the precedence diagram of the critical path analysis. But is this correct? We need to know something about the uncertainty there is on this estimate of 17. We need to have a criteria for variation. We can do this by subtracting the average from the duration, and then we square them and we add them up. So this gives us 70, and then we normally divide it by the amount of samples that we have, the amount of measures we have, minus 1, and this gives us 7.8. This figure is the variance of this distribution. The larger the variance, the greater the uncertainty is. Now, because we have squared it, we need to take the square root. And when we do so, this gives us the standard deviation. And the standard deviation is 2.8 days compared to the average. And this is rather a nice criteria for the amount of uncertainty. If I would do that for all the activities on the project, I could directly see those activities with the highest standard deviation gives me the greatest uncertainty. Very often these measures, these activities, the actual duration is normally distributed around the mean of this, the average. And in this case it was 70 and 17. Now, the normal distribution, you can calculate that when you go 3 standard deviations below the average and you go 3 standard deviations above, between these two margins we have about 99.73% of all the durations will be between these two limits. When we would go to 2 standard deviations, it would be 95.45%, and when you would go between 1 standard deviations below and above, it would be a little bit more than 86%. This can help us to discuss with our project sponsor the percentage of probability that we will actually meet a certain deadline, or we are in between certain margins of budget. We will look at that on the next slides. What you need to realize is that every estimate, it is just a guess. It's an average, and in fact you cannot say, well, this cost 12,000. No, it is about approximately 12,000, or this project or this activity has a duration of approximately 1 week. Therefore, you also need to know what is the standard deviation of this cost estimate, or what is the standard deviation of this duration. Here we've got again the mathematical formulas for those that are interested in it. These help us to determine how thick or how small this normal distribution is. In the previous slide, I have given you some percentages of probability that you are within a specific range of the standard deviations of the average. There is a so-called Z-table, and in the Z-table we can determine the probability that we are below a certain distance from the average. And this distance is always given into the amount of standard deviations. Let me give you an example. When we have an average of 12,000 and the standard deviation is 2,000, and this we know because we are experienced people in this, and we have done this many times before. So because of that, we can calculate from our historical files, we can calculate the standard deviation. And then when we would pose the question, how much is the probability that we are below 10,000? And then we look up into the set table. It's minus 1 standard deviation below the average. As you can see, the average is 12,000, the standard deviation is 2,000. So we go up in the rows. We go to the row minus 1, and there is nothing behind the decimal point. So here we get 1.0 below the average is 0.1587. So this is 15%, about 15 to 16% that we will be below the cost of 10,000. When you want to know the probability that something is, let's say, more than 1 standard deviation above the average, then you need to realize that this normal curve is a symmetrical curve. So you could also use the Z-table, but you need to swap the sign. Here you can see how this will work. Try to study this and finally, you need to realize that when you set a boundary, that everything that is below the boundary you've set and everything that is above this boundary, together it's always 1, as you can see here. Again, I will stop this presentation. Please study this very carefully so that you understand how this works. Let me give you a few examples. Again, we have an average of 12,000, a standard deviation of 2,000, and I want to answer the question, what is the probability that I will be below 70,000? First step is to determine how many standard deviation this is from the average. In this case, it's about 5,000 in absolute terms, and the standard deviation is 2,000, so we have a distance of 2.5 standard deviations above the average. And we find this over here in the Z table. So actually this is about 99% probability that we will be below this amount of money. Same question, but now what is the probability that we are below 11,000? Same procedure. First we determine the standard deviation. This is minus 1/2 standard deviation below the average, and here we will find this in the Z table, which brings us to about 31% probability that we are below 11,000. And then the last example, what would be the probability that we will end up with an actual cost below the 6,000 euros? This is about -3 standard deviations below the average, and this brings us to a percentage of almost, well, 1/10 of a percent. So actually this is a very small probability that we will be cheaper than 6,000. As you understand that you can use these techniques to get an idea, to get some understanding of the uncertainty there is on specific aspects of your project.